All right, gang, Math 5130. For those of you that just aren't digging R and prefer to use StatCrunch, I think I've made it pretty clear. I prefer R because it's free, it works, and the coding that I'm going to ask you to do in this class, I'm going to show you everything. All you have to do is just retype it. I'm going to start saving the scripts, so you'll be able to let me show you what that script looks like. It's here somewhere. Oh, a script for independent samples t-test. So I'll start giving you the script for the commands. All right, so that'll be available to you. Never done that before, but I think it's a pretty good idea. So one other thing, in the previous video for R, I forgot to add that sentence. The 95% confidence interval needs to be added. And it turns out, well, I'm kind of glad the script is here now. It turns out that value, you don't have to do anything to get it. It is right there. So just report it, which I forgot to do. All right, so not digging R, how would you do this on StatCrunch? Well, the very first thing we need to do is open StatCrunch and get the data into StatCrunch. So let's just go to Data, Load from File on my computer. And I have the data set, close SP, right there. Open it up, upload it to StatCrunch, and we're ready to do the analysis. Now, first thing is you need to change from using R to StatCrunch. And I demonstrated in an earlier video how we cite StatCrunch. So next thing, let's just run through line by line. Data set, our descriptives are on 244 patients. There's really no fancy thing to do here. Just scroll down and there you go. Next thing we want to do is report the mean and the standard deviation and median and range and stuff. So you should know by now that to do that, you go to Summary Stat, column, choose Close SP, and then start choosing the values that you want to calculate. I believe that's about it. So you can see that the mean is 0.86, which I have reported, standard deviation 1.07, then we have the median, the range goes from the smallest to the largest, and Q1 and Q3. To dive into describing the categorical variable, that's easy to do. Just go to table and frequency. And again, if I'm going too fast, just you can always slow me down by just hitting pause. Let's select frequency and relative frequency. I really like the output for StatCrunch because it gives us, we don't have to do a prop table and all that, create a table. But we can see 143 did not fall or did not report a fall, and 101 reported a fall. To get a histogram, I'm expecting this to probably look a little different. Let's just see, they may probably use different bins. They did, they used different widths for the bins, which perfectly fine. Copy that by going to Edit, Copy, and then paste it there and resize it. The box plot's probably going to look about the same. And it does. Again, copy, paste, resize, just like I've demonstrated previously. Now we'll jump into the independent samples t-test. Again, all the words are the same, and the result is not going to be significant. So how do we get these values on StatCrunch? Well, again, I don't like the way StatCrunch does this because we have to split our data into columns. It's easy to do. If I go to Arrange and Split, then I need to split close SP by fall status. And I'm just going to open this in a new data table. And now you can see that I have my non-fallers close SP scores and my fallers close SP scores. But notice that they're not going to be the same. We don't have the same number of people who reported a falling as reported a non-falling. That's fine. You can still run your t-test that way. So let's just run it. So the t-stat to sample with data. So select one column, second column. We want an unpooled test, so do not select that box. That gives you a pooled t-test. And remember, Darbo doesn't do pooled t-test for reasons I won't go into. And then we need to do, no, we don't need to do that here. Forget that. So let's just run this. So you can see that the sample mean difference, we have our standard error, degrees of freedom 208, which we've reported. Test statistic 0.24, which I've reported. 0.81 is the p-value, which I have reported. All right. The next thing I would need to do is get into the 95% confidence interval. So let's go edit. Let's report the confidence interval. And you can see it ranges from negative 0.21 to 0.27, contains 0, so it corresponds to having a test that is not statistically significant. Now, to get these means and standard deviations across, we just need to go to summary stats columns. Well, I'm sorry, I need to go back to this one. And I need to go to stat, summary stats columns, and I want to close SP, but I want them grouped by fall status. So I need the mean and the standard deviation. So you can see the mean for the no falls, 0.87, corresponding standard deviation right here. And then the one who reported falling, 0.84, 0.58, just as we reported previously. So all of the information up here, I've demonstrated how to report or how to calculate that. And I'm showing you how to report it. All you got to do is copy my narrative and change the numbers according to the problem you're working. Now, to test the normality assumption, we need close SP. It's kind of weird the way we have to do this, and there may even be an easier way, straightforward way, but this works. So if we come in with a t-stat and just do a one sample with data, and then choose close SP, if I'll come down here to Shapiro-Wilk normality test, it will run what I call a univariate Shapiro-Wilk normality test. Notice it's right here. Ignore that stuff up there. We don't care about that. Notice that the test statistic is 0.40, which I've reported right there. Notice we have statistical significance, which I've reported right there. Now, StatCrunch reports it at 0.00001, just saying we have an extremely low p-value. We don't report it that low. Remember, the reporting of p-values was covered in a previous video, so if you need to watch that, please do. Equal variance assumption for Levine. It's easy to get. Wait a minute, we have to go back to this. See, again, I just don't like this approach. One of the reasons I prefer R. But you're not me. So if I go to no, I want to go to variance stats homogeneity. So this is where I get my Levine's test for StatCrunch. So I'm going to choose both columns. I'm going to make sure the default is Levine's test. Brown-Forsyth is a perfectly good test for equal variance, but I just use Levine. If you took this class from someone else, they may prefer Brown Forsyth. That's fine. But just report Levine, hit compute. You can see our test statistic is 0.31, which I've got right there. You can see our degrees of freedom. We have 2 of them, DF1, DF2, 1,242. Talked about that in the previous video, and our p-value is 0.58. So I can put that information in this table, and then if I do want a side-by-side box plot, those are super easy to find. Well, I need to go back to this. Go graph, box plot, choose my dependent variable, group by false status, and I'll get a side-by-side box plot, which gives me close SP separated across fallers and non-fallers. So again, if I need this, copy. So Control C, come over to my document, wherever, Control V. Interesting. Copy image, and just resize, and you got it. All right, so that concludes creating the values with StatCrunch. I feel like I'm forgetting something, but I don't know what it would be. All right, take care.